Mastering the manipulation of tables is crucial for effective Lua programming. One powerful way to handle tables is by creating custom functions that can perform specific operations on them. These functions enhance code reusability, readability, and modularity, making your programs easier to manage and extend. In this tutorial, we will explore how to create custom functions to manipulate tables in Lua. We will cover 3 practical examples that demonstrate common operations. We define a custom function named SumTable that takes a single argument t, which is expected to be a table containing numerical values. We create a local variable sum and initialize it to 0. This variable will hold the cumulative sum of the elements in the table. We start a loop using ipairs to iterate over the table t. The ipairs function returns both the index and the value of each element in the table, but we only care about the value here, so we use underscore to ignore the index. Inside the loop, we add the current value to the sum variable. This accumulates the sum of all values as we iterate through the table. After the loop completes, we return the accumulated sum. We create a table named numbers containing the values from 1 to 5. We call the SumTable function with numbers as the argument and print the result, which is 15. This custom function, SumTable, provides a simple yet effective way to sum all numerical elements in a Lua table, showcasing the power and flexibility of custom table manipulation functions in Lua. In our next example, we define a custom function named filterTable that takes 2 arguments, t, the table to filter, and condition, a function that defines the condition to filter by. We create an empty table named newTable that will hold the elements that meet the condition. We start a loop using ipairs to iterate over the table t. The ipairs function returns both the index and the value of each element in the table, but we only care about the value here, so we use underscore to ignore the index once again. Inside the loop, we check if the current value meets the condition by calling the condition function with value as its argument. If the function returns true, the value meets the condition. If the condition is met, we insert the value into the new table using the table insert function. After the loop completes, we return the new table containing all the elements that met the condition. We create a table named numbers containing the values from 1 to 5. We call the filterTable function with numbers and a condition function that checks if a number is even. We store the result in even numbers and print each value in even numbers, which are 2 and 4. This custom function, filter table, allows you to create a new table that contains only the elements meeting a specified condition, demonstrating the flexibility of table manipulation in Lua. In our last example, we define a custom function named mapTable that takes two arguments. T, the table to be mapped, and func, the function to apply to each element. We create an empty table named newTable that will hold the transformed elements. We start a loop using iPairs to iterate over the table T. The iPairs function returns both the index I and the value of each element in the table. Inside the loop, we apply the function func to the current value and assign the result to the corresponding index I in newTable. After the loop completes, we return the new table containing all the transformed elements. Once again, we create a table named numbers containing the values from 1 to 5. We call the mapTable function with numbers and a function that squares each number. We store the result in squared numbers and print each value in squared numbers, which are 1, 4, 9, 16, and 25. This custom function, mapTable, allows you to apply a function to each element of a table and create a new table with the results, demonstrating the power and flexibility of functional programming in Lua.